Hello everyone. Today we will learn functions, for loops, and if-else conditions. Now, prior to today, in day one, we learned about shell script, JIT, command line arguments, user input using shell scripts, and arithmetic operations inside of shell scripts also. Now, in day two, we did intro to C language, tested some built-in functions, learned how to use variables and also arithmetic operations. Now, today day three, we'll learn about for loops, if conditions, or if else conditions. We'll also learn about for loops and then functions. Now let's begin. Let's create a new folder for day 3. Nope. Day 3. Now let's create our first file for day 3 also. Let's say for if condition, or let's say conditions. Conditions.c. Now an if condition is a statement that checks if a value is true or false, then performs an action, and then if there's an else statement, it goes ahead and checks the other statement to see if that matches. Now let's go ahead and test that. First we have to include main.h, stdio.h, include stdio.h int main void. Now let's go ahead and document our code. Main, entry points, description, conditional, statement in C, return 0 always. Now let's initialize two variables and check if they match each other. Now let's say int a equals, let's say 20, int b equals 18. Now let's write an if condition to check if these two values are the same thing. So now if a equals b, print f a is equal to b. Now what this does is we initialize two variables. Now we are trying to check this if condition. This is the if if keyword, and then this is the statement we are trying to confirm. We are trying to check. Now this if condition will return true, and this line of code will run only if this value that is here returns true. Now we are saying if a equals b. So what the equals means is it's a question, like does a equals b. Now if you use a equals b, as in this case, it's an operator that copies the right to the left. So here we're trying to initialize a variable. Well, now if it's double equals to, then it's a question, it's a condition. Now if a equals b, that means does a equals b. Now whatever is under this block would only run if this statement returns the true command, the true response. Now if we are saying if a does not equals b, that's a different thing entirely. But now let's say if a equals b, let's print and see what happens. So now let me compile my code. Now cd day 3. Oh, forgive me, I messed up my terminal. I'm here now. So cd day 3. Now let's compile our code. gcc conditions.c output file conditions. Now our code has compiled successfully. Now let's run /conditions. So now you can see it did not like return it, did not print anything. That's because we didn't, a does not equals b, right? So then this line of code did not run and there's nothing else, so it just stop. But now if you want to check a statement and then check another statement, like, and then like return a value or do something else if it is not true. Now here we want to check if a equals b, they want to like print a is equals to b, right? But then what if a does not equals to b? What do we want to do? So then we have an else statement, else, and then would have whatever is here that would run a is not equals to b. So this checks these variables, right? And then only prints this value if a equals b. But then if it does not equals b, it now goes on to this place and run this block of code. But then if it equals to b, it's only run this and then to skip over this block because it's only else. So this is like saying that, okay, go and get my book if you can find it there. But if you cannot find it there, you just come back and tell me my book is not there. So this is the same thing that is doing here. Check if a equals b, then print out a is equals to b. But otherwise, if it is not, if it's not true, then go ahead and like run this block of code. Now let me go ahead and recompile my code and see what happens. GCC conditions dot slash. So now you can see a is not equal to b because it checked this statement and found out that it was false, then went ahead to this one to like run this block of code. So then let's check now if this statement returns true, what will happen. Let me go ahead and change this variable to 20 and compile my code again. Now a is equal to b. So now you can see this statement returned true this time. So when we check a equals b, it's returned true because a and b are actually the same value. So now it's to print out this block and skip the second block. But now let's say you want to check on this if statement another value. Let's say else, but if again, else if. Oh, sorry. Else if, we need the statement there also. So else if a greater than 0. Now print a is greater than 0. So now what this does is, let me clear my terminal. What this does is it checks here now for the condition, does a equals 0. If it is false, it now go to this place and now check again. Not only does it come, it comes here, but now it checks again if a is greater than 0. Now if a does not equal 0 here, it now checks again, does is a greater than 0. If it is, it will print out this block and skip this block. But then if that is also false, it's now come back here and just run this block of code. So now let's say, let me recompile and /conditions. So now a is equal to b, that works fine. Let's now say a equals 0. Let me recompile. A is greater than 0. So now you can see a is 20, a is greater than 0. So that's what it printed here. But now it did not print a is equal to b because we have checked the condition here and we have like returned the values that we want. So now let's go ahead and make this different. Let's say minus 20. Let me recompile my code and run. So now you can see it checks this condition. Is a equal to b? No. So it skips this block and moves on to the next one. Now it goes ahead and check, is a greater than 0? Still no. So it goes on to the next block and check. Since there's no check yet, it does like print out the statement. A does not equal to b. Now let's go ahead and make something different out of this. Let's say check age. Let me delete all of this. Age int age equals 20. Now if age less than 18, less than, or let's say 15, print f, you are a child. Now if age. Should we let's use 13 here instead. So now let's say we don't want 20 here. Let's use 18 instead. So now 15 to 18, a teenager. But now else if in this case else. But now in languages like Python, we don't use else if. You could use it, but we use elif instead. Elif, elif. So that's just short for else if. But we should not worry about Python right now. So now let's say if age greater than or equals to 18 and less than 21, you are a young adult, and else print off you're an adult. Now let's go over this again. We initialize the variable age, then we checked if age is less than 13, then you should print out you are a child. But now else if, now this expression here is greater than or equals to, so we cannot really like type that out in the code. That would be quite slow. We just have this short form for greater than or equals to. Now if you want to like get less than or equal to, you just use less than and then equals to as of this place, but we don't need that right now. So then we check, does age greater than or equals to 15, and also by the same time less than 18. So here we're trying to check if the age falls between 15 and 18. So that's why we have two expressions using the AND operator. So now we can see logic gate actually. So now we can see age greater than or equals to 15 and also age less than 18. But now if we use the word, if we use or here, this one instead. No. Okay, we'll do that later. There's another condition that you could also use here, like is or. So you could use hand and or. So what that does is okay. So now this checks if age falls between the gap of 15 and 18, then prints out okay you are a teenager. But then for the else if that is here now, it checks if age is in between 18 and 21, then we say you are a young adult. And then otherwise, if the age does not fall in between these groups, person has to be older than 21. So we are saying you are an adult, like straight up. Now let's see how this works now. Let me compile my code again. Young adult, because we are, this is the age is 20 now, so you can see now the age falls in between 18 and 21, so you can see you are a young adult. Now let's change this age back to something like 12. Let me recompile my code, and now you can see you are a child. But if it's exactly 13, you'd see what happens. You are an adult. No. Okay, we didn't write the statement properly for that. So now we didn't write a statement for if age is greater than 13. So then we should have, instead of 15 we have 13 here. So let me recompile now and see if we have the right response. So from 13 to 18, consider the teenager. So now you can see we have 13 here, but we have 13 here, but that still didn't work because we are saying if age less than. So 13 and 13 is equal to, it's not less than, so that's why it doesn't carry this out. It goes ahead to the next one. So now you can see here also it's greater than or equals to. So then you can see it's equals to now, so that's why it worked. But if it's also greater than exactly 14, it would also still work because it's greater than. Let me go ahead and recompile. It's still you're a teenager. Now let's go ahead and see how 18 does. 18, you're a young adult because it falls in between this block of 18 and 21. So that is that about that. So now we could also compare strings. Let's say now to initialize a string, use the char star name equals John, and then Joe if so now you can see the AND operator here. So now if name equals John, so then this is the name that is here now, name equals John, and this is and the AND logic gate. So you can see and surname equals though. So this thing has to pass two tests. the name has to be equals to John, and the surname has to be also equals to Doe. Now let's see how this works out. Let me recompile my code. Now you can see you are John Doe. But now if one of these tests pass, that means we have John and not Doe. Let's see something else is here. Now you can see we would have you are not John Doe, because it only passed one of the tests, not the two. That is what a hand is used for. So you have to like pass both sides, this side and the other side. It has to like return true simultaneously. But then if we are using the and, let's say now this is the or operator. This like single lines double. So now if name equals John, or surname equals Doe, you are John or Doe. So now you can see you are not John or Doe. So now let's move ahead to the next one. Let's test it and see how this happens. So now you can see for the second print you are not John Doe, but now you can see here you are John or Doe because it passed one of these tests. If it passed one of these tests, then it's like continue with this block. But then if it doesn't pass any of these tests, it will not continue. Let's say John changes. Let me recompile my code. You can see you are not John or Doe because none of the tests pass. Both sides return false. Now let me change this back and John. Now also if both sides pass, it will still run the code otherwise. Now let me recompile and see. To still work, you are John or Doe because both sides passed. So the OR logic gate allows when true and true is the response of a value, you get true as output, which means it will run this block. But when true and false, it also like get true as output. So inside the OR logic gate, true and true equals true, true and false equals true, false and true equals true. So that is why whichever of these tests that pass would still print out this block because it only needs one true to work fine. But then the AND requires that both sides are true. So true and true equals true, but true and false equals false for the AND logic gate. So that's how this works. Let me also return 0 at the end of this block, and let's move on to something else. Return 0. So now we have that. Let's learn about for loops. Let me move on to a new file. For loops.c. Now here we'll learn about for loops. Let me include stdio.h, stdio.h int main void now let's document our code before we begin. So now we have main entry point description loops in C and return 0 always. So now a loop is a statement that enables you to do a task multiple times. So you want to like continue doing some set of events or some set of tasks continuously for a set amount of time. So now let's say int I equals 0. Now there are different types of loop. There is the for loop. Let me go ahead into readme and do that actually. Let me create a readme in this folder. No. readme.md. Now loops. There are different types of loops. One of them is the for loop. There's the while loop. There's the do while loop. So like these are different types of loops that you could use in C and some other languages. So now the for loop goes like this. Now we initialize a variable which is the starting point of the loop. Now int I equals 0. So now you can see this statement looks quite cryptic, to be honest. If you are not a programmer before, you probably won't understand any of what's going on in this statement. But let me break it down for you. Now this checks I equals 0, so this is where I begins. Now for the first round of this loop, we have I equals 0. So now we know that I, as of now, equals 0. Now here we can see I less than 10. So it will continue this statement that is inside this block until I is no longer less than 10. So it like continue this, continue until I does not less than 10 again. So now you can see we are beginning from I equals 0. So now I equals 0, I is less than 10. So it will continue this loop. Now it continue the loop, continue doing the same thing over and over and over again until I is no longer less than 10. So now this is the final statement that is like required for this thing to work. I plus plus. So now after every loop, this is what will happen. I plus plus is the same thing as saying I plus equals to 1. Like I equals I plus 1. So now you can see, let me go over this again. We begin at I equals 0. The loop will continue until I is no longer less than 10. And then for every loop we add 1 to I. That's what this does. I plus plus. This is the same thing as saying I equals I plus 1. The same thing. So just a short form in C language, you say I plus plus. So let me go over this again. We have I equals 0, which means at the first time that the loop starts, I will be equals to 0. And then we'll continue the loop until I does no longer less than 10, which means I will be equals to 10 or higher. Then for every loop we want to add number 1 to I, so it will not continue forever. Now if you should say that okay, we want to continue this loop for as long as I is no less than 10, and we don't add 1 to I, which means it will just continue forever. But now we want to like add 1 to I, so like it will keep increasing every time that the loop passes, and then after a while I would no longer be less than 10, which means the loop will stop. If you don't do it like this, you end up in an infinite loop. It just continues to run and continue like that. So now let me run this now and see. I is equal to, let's control J, and now let's see what happens. gcc loops dot c and then -o loops. Now let me run /loops. So now you can see it continues to print this block 9 times actually. 0 actually is 10 because we start from 0. Now this is one of the things you should know. In the common programming sense, we don't begin counting from 1. It's not our habit. Or the people that design programming or like design the first languages decided that we should begin counting from 0 for some reasons or the other. I don't want to care about that right now. So we always begin counting from 0. If you want to count to 10, you start from 0, then go to 1, and then 2 all the way to 10. And then now you can see it didn't reach 10 here because we said continue until I does no longer less than 9. So now you can see if it continues here now and I becomes 10, it will not print because I is already like it's no longer less than 10. 10 equals 10, so I is not less than 10, so it does stop. Now let me just show you another example of this. Now let's remove all of these values. This might be quite confusing for now. Let me just say hello. So let me recompile my code, and yeah, so now you can see it continues to print hello for 10 times. Let me print a new line so you can easily count it. \n. No, we don't want that. So now hello \n. So now to print out a new line for us. So now when I recompile my code and run this, you can see it continues like that. So 1 2 3 4 5 6 7 8 9 10. So it begins counting from 0 and then goes all the way to number 9. So that's like ends up in 10 numbers that is printed in total. So now let's move on to something else using different loops. Let's use the while loop instead for now. Let's say while and then the statements. Now while I less than 10, so this while means continue this block of code as long as this statement returns true. So remember we use those logic gates here now. So this here says that whenever this statement returns true, just continue this block of code, continue to do it again. So now if this statement no longer returns true, if it returns false, then the whole loop will just stop. That's the end of the loop. Now let's see what happens here also. Now we print the number and then we say I plus plus, like the other one that we did in the for loop. So this I plus plus is like important for every loop that you're working on. You have to keep increasing your counter, so to say. The I is the counter. You have to keep increasing it, otherwise you just end up in an infinite loop. Now let's recompile our code now and see how this works also. So you can see it printed 0 to 9. But then let's say we did not print let me remove this printing of this variables here. Let's just say loops, and then let's remove this high plus plus so you can see what will actually happen if you don't increase your counter while you are using loops. Let me recompile my code, and now you can see it just continues and continues and continues. It never stops. You can leave it like this for a day and it just continue to work, continue to print loops like just continue to, until you just like tell it to stop using the control C in your terminal. So whenever you are an infinite loop in your code, use control C and then to stop whatever program you're running and you want to stop it like by force, just use control C and then to like stop the program or the script or whatever you're running. So now that is why you need to use high plus plus, so it continues to increase your variable, or if you don't increase it, you see what happens. It will become an infinite loop that just continues to run until thy kingdom comes. So now let me I don't want to just remove the for loop like that. Let me copy this, and yeah, so we'll still have the for loop, and then we'll have this also. So now let's say the do while loop. So do while. Now this do while loop is, this one just goes, it's continue the loop for as long as Earth is existing. So this do while means just run this block of code. Then after running the block of code, go ahead and check this value. So now you can see here now, we check the value first before running this block of code. But in the do while loop, we run the block of code before checking the condition. So now you can see, let's test this now and see. Let me recompile my code. So now you can see hello loops. Why? Okay, now I see why that is. So now you can see we are using the same variable, right? Let me run this again so I can explain this better. So now inside of this place, I said int I equals 0, right? And now inside of this loop, we keep increasing I. Now I equals 9, right? When we stop this loop, I equals 9. But here I said, no, I equals 10 actually. But here I said while I is less than 10. But I is already 10, so it will not do anything. Same with this place. I is already 10, so it's not doing anything. But now if we count this now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it stops at this loop. Doesn't do any other thing. Because I is already equals I already equals 10, and it's not just continue any of the loops, because the statement is now returning false for all of the loops. Now let's go ahead and change this value. Let's say create a new counter for this. Int j equals 0, and then here we use the word the letter J. Now here let's say int k equals 0, and now let's use k. So now when I recompile my code, all of these loops will run. Now we have an infinite loop again. Why is that? So now we stop at loops. It's working fine for the hello, but then the loops began and it's an infinite loop. So let's see what's wrong there. Remember we said here now that we want to keep increasing high inside of this place. But now here we said int j equals 0, j less than 10. But then we didn't say j plus plus, we said high plus plus. So it's continued this loop forever, because j will forever remain 0. We are supposed to increase the variable j here instead of high. So then it's just keep increasing I, and then we are trying to use j, so it just continue and continue like that. So that's one of the other ways to get into an infinite loop. You should always like check out for things like that. Now let's move on to k. Also, if we did not change this, it's also like enter an infinite loop. So now let's go ahead and okay. Now let me recompile my code and then run it again. So now you can see hello loops continues like that. So let me change this. Do while loop. Do while and then here also. So now let me recompile my code and see what this looks like. So now you can see we have loops that printed hello, then loops, then do while loops. So that's the difference. That's how to use loops. You could use loops for several reasons. Let's see one of the ways you could, one of the reasons you could need the loops now. Let's say int mm, j int list 5 equals. So now this is a list object type. This is a list data type. So now, as one of the data types that we have in C language, we have what is called the list. Now this list is only going to contain like integers. So that's why we said int. This could be anything. This could be my list. This could be names or numbers. But now for this sake, I just decided to use list. So now this list is like an array of objects, of numbers in this case. Now this, it contains this set of numbers. So now if we want to print out the entire content of this list now, we could use a for loop for that. So now let's say for L equals to 0, L less than 5, which is the length of our list, and L plus plus. So it will go through this list, check the first value, and then print it out. So let's test it and see how that works. Let me recompile. And now you can see 1, 2, 3, 4, 5, which is the values of this list that is printed. Now, so you could confirm that it's actually the values, let's say 18, change the values a little so it's not just increasing, something different. So let's say 1, 2, and then 5. So let me recompile, and then you can see it printed out the same values of the list. So now let's go through this again and understand how it really works. So this int list means I want to have a list of variables, an array of variables that will only contain integers. So that's why we have the int here. And now this 5 that is here is like the length of the list I want. So I'm already telling like C language or my computer that I'm going to have a list of values, and that list of values will only contain 5 values. So that's what I did here. Then now I now said it contains this set of 5 values. Now if I change something here, let's say I add 9. Let me clear my screen, recompile. So now you can see here we have an error. In also to learn, usually how to debug like this, now we have loops.c in function main. So it's telling us where this code is coming, where the error is coming from, function main. Now you can see line 32. This line of code is where we are having our errors. Now warning, excess elements in an array initializer. So now you can see here that we said 5, but now we're adding an extra value which is wrong. That is why it's throwing out an error for us. So you have to like know the length of what you want before like initializing it. Now let's say, let me recompile. It still works fine. So now let me explain how this works perfectly. So now we've learned how to initialize a list, right? But now how do we loop through the list? Now as you can see here, we initialize a variable. It's L equals 0, which is the starting point of this our for loop. Now we said L less than 5, which is the length of the list. So we want to continue this statement that is here for as long as L is still less than 5. So like we want to continue for the length of that list. Now let's say L plus plus, so we are increasing our counter. Now what this does is it prints, this is our placeholder for a number that we're going to be printing. But now this list of L, this is called array indexing. So what this does is, you know, whenever we are running a loop, this L value, our counter, would always contain a value. Now when we begin this loop, this L will be equals to 0. So now when we are saying list square bracket of L, so it will be same thing as saying list of 0, right? Because L will be substituted for that and then it becomes 0. So now what this does is it goes into this variable, this list variable, and checks which value is on 0. Remember when I said we always have 0 indexing, where everything begins to count from 0 in programming. So now the first value of this place is considered at position 0. So it goes ahead into this list and finds which integer or which number is inside position of 0. So now this is return this letter for this number for us, because 1 is at position 0. Then it goes ahead to the second loop of the list. This becomes 1, and now it goes ahead and check again which value is in the first position, which is the position 1. It return this value, which is the 18, and then print out 18 for us also. It continues like this until the end of the list. So that's how that works. Let me change this back to I. And now let's move on to something new. Let's learn how to build functions. Now let's create a new file here, functions.c. Now functions, like, we use the printf function inside of this code. Now the printf is a built-in function. It was designed by the people that wrote C language, that designed C language. Now we want to design or develop our very own functions to do our very own tasks, right? It's not really right for you to write blocks of code to be very long, but then you have to write functions to make your code reusable. So that's the right way to do things. So now let's learn how to develop functions in C language. Include stdio.h function in C. Now int main and void. Now before we go ahead and populate our main function, let's define a new function. Now before you define the function, you need to understand how exactly the function wants to work. So now we want to design a function to add two integers. Now we should know now the function will take two values as inputs. The first number that we want to add and the second number that we want to add. So we want to add two numbers. So our function will take two numbers as inputs. Now also, after taking the two numbers as inputs, we want to return the sum of the numbers, which means we are returning an integer also. So now this int, this is the value of our response, right? We are going to return an integer. If you're returning a float, then you have to use float, because we're returning a floating point value. But now we are returning an integer, so let's say int. Now the name of our function, add. So this is the name of our function. Whenever I want to use our function, we call add, and then it will work fine. Now int a, this is the value of the first input to the function. That's integer, and then the name of the integer will be a, and then let's say int b. Now outside of here, now we can now say return. This return value, this is where it's important, a lot. A plus b. Now let me go over this again. We have a function that wants to add two numbers, which means our function will take two numbers as inputs. This is the input of our function. Now in the case of this main function, we are not taking any inputs, that's why it's void. So now this our own function, we are taking two inputs, which is a and b, two numbers. That's why we have both numbers inside. If you want three numbers, you have to add one more number here, which means int c, or whatever it is that you want. You could name this whatever you want, it will still work fine. But then let's stick to two numbers right now. Now the return value, which means I want to return a response, I'll be returning an integer, so that's why I have int here. So now let's go ahead and test our variable to now see our function to now see how it works. Let's say print, let's initialize variables, int number equals 92, int num2 equals 42, and now sum, int sum equals add. So now let me explain this. Here we initialize two variables, as we know. Now this int sum, right, is taking is going to be storing a value, which is the response of this function. So now here we are calling this function. Remember we said int a and int b here. So this a and b, when you are calling the function, could be anything. I could write 1 and 2 here and it still work fine. So here we are passing in two values into the function. The first number 92 and the second number 42. So now whatever is returned inside of this function, whatever this function returns to us, would now be stored inside of this variable sum. Now let's print it and see what happens. Print f. So now you can see the sum of blah blah blah. Now let's go ahead and compile our code. So gcc functions.c-o functions. Now we have an error, implicit declaration of the function add. Now this is a computer, right? Let me explain why this happens. Now what it's telling us now that we are calling a function that is not existing, because now when our compiler goes through this code, it starts from top to bottom, right? But now here it's seeing the main function, right? Now here it's seeing that we are calling a function, but it has not seen the function yet. So it's like it's been like, okay, what the hell is hard? Because we've not really specified that this hard function is supposed to be there. It does not see that it's existing yet. Now normally you can read through this code, but now when the computer is reading through, it reads from top to bottom, which means as of this part of the code, it cannot see that this is existing. Let me now clear this now. One way to fix this is moving your function up to the top of your code. Doing this, pasting it here. But then this is not the right thing to do, because when I want to read my code, I want to read the main function first. So this is not the right thing to do. The best way to fix this is having your declarations before your main function. So here I'll be having ints, the same values, like this same block of code, this same block, I'll be having it on top here, but then I will have a semicolon right after it. So what this does is it tells my compiler that, okay, this function somewhere in my code is going to exist. I don't know how it will exist yet, but I know it will exist. So now you have to add this semicolon at the end of it, so to show that, okay, this is does a declaration that, okay, this function would exist somewhere in my code. Don't care about that yet, but it will exist. Just know it's existing. So now it's not return an error, because later in the code to now check, okay, now see that, okay, this function truly exists. That's how it works. Now let's go ahead and recompile our code. Now you can see no errors, because we've told it that it's existing before we used it. Now let me run not loops /functions. Now you can see the sum of 92 and 42 is 134. So as you can see here, we have successfully added the numbers and returned the value. But now if we did not return a value here now, and we just had the numbers here, it will not work fine, because we are not returning, providing the outcome of the code. Let me recompile, and now you can see the sum of 92 and 42 is 92. It's wrong, because we did not return any value. So now let's go ahead and change this back. It works fine. So like this is the way to use functions in your Python, your C program. Forgive me for that. So thank you. If you have any questions, please leave them in the description, and I'll be sharing the links to the GitHub repository for this in the pinned comments. So thank you. Leave your questions in the comments. I would respond to them as soon as humanly possible. Thank you for watching my video. Please like and subscribe. Goodbye.